Hello everyone, today we want to generate a LoRA model by fine-tuning a model using Kohya. What does fine-tuning means? Means generating a new model from an already trained model to improve its performance or to perform a specific task. Differently from training a model from scratch, where you need to use thousands or more of images, fine-tuning allows us to generate new styles, new objects, new subjects in your image or video, just using a few images. If you don't know what a LoRA model is, I made a video already on what they are and how to use them. And the dimension of the LoRA model is way smaller with respect to the base models like Stable Diffusion version 1.5 and all the other checkpoints. And this means that also training will be quicker. So what's really important for this video is that by the end of it, you will be able to generate your LoRA model. I will show you which parameters I used for my training, but this can be different for your training, right? So what I want to do is instead of giving you just numbers, I would like you to explain you how the main parameters work in a neural network, which is Stable Diffusion, meaning that I want to give you the tools for making a decision on which parameters to use for your training. For training the model, we are going to use Kohya. You can find Kohya in this GitHub page. The installation process is super easy. And then we are going to use Stable Diffusion for testing our trained model. Once we initialize Kohya, this is the main interface. And here you have different tabs, right? You have Dreambot, Dreambot LoRA, Dreambot Textual Inversion, Fine-Tune and Utilities. In today's videos, we are going to use two tabs. We are going to use the Dreambot LoRA for setting our parameters and training our model. And then we are going to use the Utilities tab, useful for captioning our pictures, our training images. So the first step is to decide what to train the model on. So let's talk about images. We have two types of images. We have the training images and the regularization images. The training images are those used for training the model. So the model will learn different features, different characteristics within the images. The regularization images are used for the training not worth it. So while the training images needs to represent what we are training the model on, so in my case, it will be my face, the regularization images needs to represent the class of the object subject we are training the model on. And in my case, it will be woman. For training a LoRA model, we don't need many images as training images. So we just need for object and subjects between 5 and 25 images. But if you're training for a style, you'll probably need more, something around 100 images. Or even more. Quality of the image is very important. So it's better to have less images but of good quality rather than having, a lot of images but with very low resolution. The only requirement for the training images is that they need to have the same file extension, which can be PNG, JPEG, JPG. It doesn't matter if they have different dimensions or different resolution. The model I'm going to use for my training is this one, which is Realistic Vision version 2.0. And from Civit AI, you can see what was the base model used for fine-tuning this model. And in this case, it's Stable Diffusion 1.5. So I have this folder here with all of my images. I'm using 25 in total. And as you can see, I have different expressions on my face. This is because I want the model to learn different facial expressions. So if you don't want the model to generate all of your images looking towards the camera, you need to train the model using images where you're looking on the left, on the right, up, down. And what is important is also that you wear different clothes and you have different backgrounds. It's not required, but it's really recommended that each image has a caption, a text file connected to each image describing that image. Captions can be created manually if you have just a few images. Otherwise, you can use Kohya. And if you are in Kohya, you need to go into the Utilities tab here, and then you have Captioning, and then you have 4 different tabs where you have different techniques for creating your captions. I find BLIP captioning being the best. So let's copy the directory of this folder. We go back to Kohya and we just paste it in here. I'm gonna use BLIP captioning. You can use whichever you prefer. And I'm gonna paste in here. So now this is my directory to that folder. Caption file extension is text file, which is fine. You can decide whether to add something before the description using this prefix to add to BLIP caption, or something to add after the description. In that case, you will add something here. This is completely optional, right? I can, for example, add a photo of, I'm not gonna add anything in the postfix. Then I think that's it really. Like, you have these other settings which are more technical. Apart from max length and minimum length is just how long you want your description to be, but this beam search and top P are more technical settings. Beam search is an algorithm for getting the best output, so I would recommend it to using and not to change the other parameters. So once you have all set, you just press on caption images, and if you go into your terminal, you will see that it will start loading BLIP caption and it will start creating these text files. It shouldn't take long. For 25 images, it took me 4 seconds. And then captioning done, we go back to our folder and you will see that you have a lot of text files next to your picture. So let me take this picture, for example. I'm gonna take the text file corresponding to this picture, and you will see it says a photo of a woman in a red hoodie looking at a cell phone. Obviously, I wasn't looking at a cell phone, but just had my eyes closed. So if you want to improve your captioning, you should do that. Obviously, when you have a massive database, you are not able to do that, but maybe you can just, tweak the description of just a few images, the most important, I would say. But what I would suggest you is to not rush. So when you're training your model, just be patient and try to make everything as perfect as possible. So in my case, I did change all of the descriptions for all of my pictures. They are just 25, so it didn't take a long time to me. So what I did, I just open the text file and I was like, okay, I'm not looking to a cell phone, so I can remove this. I can add eyes closed. I can add head bended forward. I'm going to add ponytail, and I actually have a red hoodie, so I'm happy with that. And I can add wearing earrings. So once I've done this, I'm just gonna close it and save. You don't have to describe each features of your face. So for example, I am brunette. If I want the model to generate all of the pictures exactly like me with brunette hair, I don't have to specify brunette because the model is gonna learn that Laura is brunette. But if I want the model to generate myself with blonde hair, then in that case I need to specify that. So in that case, I'm going to write a photo of Laura brunette and then the rest of the description. Something that you want to describe is also the background. So if you have, plants or kitchen on your background, that's important to specify that into your model. So once we have our folder with our pictures and captioning, we need to create the regularization images. Regularization images are optional, but also in this case, I would really recommend you to use them. They really make the difference in most of the cases, even if you're just training a face. As I said before, these images should represent the class of your subject, object, or style. In my case, it will be woman. How many regularization images? Well, you need to have plenty of them. So if you have 25 images, which is my case, I would recommend you to have at least 1 or 2 images for each training image, and then to multiply this by the repeat number you are going to use. Repeat is one of the parameters you can choose during your Kohya training, and it's very important because this is how many times each individual image, training image, gets put into VRAM. And in my experience, this should be around 100. So it means that each image gets put into the VRAM 100 times. So if you have 25 images and 100 repeats, it means you need to have at least 2,500 regularization images. Now, obviously these are a lot, but I have a trick for you to generate these images quickly. So the trick is to go into the realistic vision, which is my model, my base model. I'm going to get the generation data for one of the images I like. I go into Stable Diffusion. I'm going to paste this generation data in the positive prompt. I'm gonna press this button, and then what I'm gonna do, I'm gonna change this positive prompt because I want to generate just the class representing my training images, which in my case is woman. So what I will do, I will remove all of these useless descriptions and this one as well. And I'm just gonna type woman. That's it. I'm gonna remove the high resolution fix, and I'm gonna use 512 by 512 also for the regularization images. So I'll change this. I'm going to use a random seed because I don't really need to use a specific seed all the time, otherwise I'll get the same image all the time. And then let's press generate quickly. Oh, very important obviously is that you are using the model you want to use as a base one, which in my case again is realistic vision. And so you will see you get a picture of a woman. Now you can generate a lot of images in a loop. So you just need to right click on the generate button, and then you can see this generate forever. So this means that as soon as one image is generated, it's gonna generate another one, like in a loop. So if I press this, you will see now this will start. And you see it doesn't stop, it just keeps generating images. And then the nice thing is that if you add different features to your prompt, like for example blonde, this is gonna change. In this case I don't want all blonde, so maybe blonde is not ideal. I can maybe put American or European, just to have a little bit of diversity. But once you found a good prompt, you can keep this loop generation until you generated the 2,500 or more images. And then once you're happy with that, you can stop by right-clicking on this same button. And then you have cancel generate forever. So this will stop the generation. So I generated all of this. This is my regularization image. And I generated 3,475. And you can see that I have diverse images of women. Now, I know these are a lot, but I would recommend you to clean them a little bit, meaning that, I don't know, if you have, I had, for example, some images where there were just women eyes, for example. I don't need that. I need the entire face of a woman. So in that case, I just canceled these pictures. And it's fine if you have some which are not perfect or they are low resolution. It really doesn't matter. So now we have created our training images folder and our regularization image folder. So what we can do, we can start adding these folders into our Kohya. Let's go into Kohya and let's go into Dreambot LoRA. The source model tab is the first tab and is very important, and is where you are going to choose the model you're going to use as a base model. You can quickly pick the model from this drop-down list. You have some models in here already, like you have Stable Diffusion 2.1, you have Stable Diffusion version 1.5, version 1.4. If you want to use a different model, you will need to type the path to the model in here. Before doing that, I would like to show you that you have here two different checkpoints. You have version 2, which you need to tick if you have a version 2 Stable Diffusion model, and you have V-parameterization, which you need to tick if the model was trained on 768 by 768 dimensions. If you pick the model from this drop-down list, these two checkboxes will be automatically updated. So as you can see in this case, in Stable Diffusion 2 base, it's a version 2, so this was ticked, but it was trained on 512 by 512, so this wasn't ticked. Now, if you're going to use your own model, you will have to be aware of these two checkboxes because they are not automatically updated. So what I'm going to do, I'm going to click on this folder, and I'm gonna dive into the folder where I have my model. I have it in my Stable Diffusion models, Stable Diffusion, here you go. So this is the folder where I have all of my Stable Diffusion models. So I'm going to select the folder, and then you need to add the name of the model. You add a backslash, and then you go into Stable Diffusion Web UI, you go into models. Well, you obviously need to go where your model is, right? So I have it in here, Stable Diffusion. And then I need to copy the name, can go into properties, and I just copy the name of my model. Go back here and I paste it in here. Now, I know that the realistic vision, and you can see that from the main page, it was trained based on the Stable Diffusion model 1.5. So you don't need to tick these two boxes, because as we saw before, if you choose Stable Diffusion 1.5, these are not ticked. So I'm gonna now change this again. So I'm gonna paste mine and I'm gonna leave it like that. So this is the first tab we need to fill. Then save trained model as Safe tensor. Safe tensor is completely fine. Usually that's what LoRA models are not checkpoints. Actually, checkpoints and safe tensors are the same thing. Is the only difference that safe tensors are safe, as the word says. So it means that they cannot contain bad code. Then after that, we go into tools, which is where we are setting up our folders. So let's do that first. You have training images here, so you need to click on this button. And then you dive into the folder where you have your images with the captions, and you select the folder. You do the same for the regularization images, which I have on my desktop. Select folder, and here is the path to these folders. And then you need to also create a folder where you will want your model to be saved after training. So I'm going to create a new folder. In here, I have different training, as you can see. I'm going to create a new folder and I'm gonna call it training 13. You can call it whatever you want to, right? So I can go here, you click in this folder again, or you copy and paste directly the path, or you just dive to that folder using this. You can do both, what's easier for you. And you select folder. Actually, I picked here the wrong one, so instead of images, it should be image, because it's where I have my captions as well. So I'm just gonna, change this to... Here you have the instant prompt and the class prompt. Class prompt is woman. So I'm going to type here woman. If you are training your model on cats, dogs, you will have cat or dog. If it's a toy, you're gonna write toy. If it's an anime girl, you probably want to type girl 1. And then here you have the instant prompt, and it's basically the name of what you're trained. And in my case, I'm gonna use my name, which is Laura. What seems to be very good is to use some numbers in the name. So for example, instead of typing Laura like this, I can swap the A with the 4. So like Laura, like that. I don't know why, but this seems to be working better with the model. So the instant prompt plus the class prompt is what we call the trigger word usually. So once you have trained your model and you want to create the picture of yourself, you will need to write in the positive prompt a photo of Laura woman. We have a look at this later anyway. Then you have repeats. We talked about repeats before. So this is how many times the image is put into the model, right? We could call this iteration as well. I found that a good number of repeats is between 70 and 100. So I'm going to use 100 in my case because it was giving me better results, but I would recommend you trying different number of repeats as well. And then I have plenty of regularization images and I'm going to use one for them. That's completely fine. If you're not using regularization images, obviously this repeats number doesn't matter, really. So once you are done with that, you just need to press Prepare Training Data. And then you will see, if you go into the folder you created, which was Training 13 for me, you will see that there are 4 different folders inside where you have images for training the model. If you click inside that, you have 100, which is the number of repeats, and the trigger word, which is Laura woman, right? And if you go inside, you have the images with the text file. Great. Then you have the log file, which is the folder where the log file will be saved after training the model. So it's actually empty now. You have model file. Again, also this is empty as well because it will be filled after training with the model trained. And then you have reg, which is the folder for the regularization images. So if I click here, I have 1, which is again the repeat number, and woman, which is the class prompt. And I have all of my regularization images in here. Once you have this ready, you can go back into Kohya and press copy info to folder tab. Then you swap from tools to folders tab, and you will see that this tab has been filled with all of the, you see, all of the path to the new generated folders, which is great. So everything is automatic. The only thing I would suggest changing here is the model output name, which is simply the name of the model you're going to create, to generate. And I want to call it LoRA face _face. Once this is done, so we fill the source model, folders, and tools, we need to go into training parameters, which is the most important tab because it's where we are setting our key parameters. I'm not going through all of these parameters, but I'm gonna show you and explain you the most important ones. But before doing that, I would like you to understand how a neural network works, because when you are training a model, it's very important to understand how a model works. And just in that case, you will be able to choose what's best for you, right? And you can understand as well how you can move the parameters, how to change the parameters in order to get an optimal trained model. So a neural network is a computing system inspired by the human brain, and it's made up of layers, and they work together to make sense of data. The layers can be divided into input layer, multiple hidden layers in the middle where all the calculations and the magic happen, and then you have the output layer, which is obviously the final result. Now, let's imagine that you're training a neural network to recognize a cat. So what you will do, you will start with a large collection of cats, which is input inside the neural network. Each image is divided into pixels. So once they are input inside the neural network, each layer between the input and the output layer will try to identify features inside the pictures, the images. And the deeper the layer, so the higher the number of layers inside the neural network, the more the model will be able to identify more complex patterns inside the images. For instance, the first layers will be able to recognize edges of the image, and the deeper you go, the layers will be able to recognize the ears, the nose of the cat, and so on and so forth. Training a neural network requires a lot of trials and errors. So initially the network will be not very good in recognizing cats, but every time it makes a mistake, it's going to provide a feedback and it's going to adjust the network based on that feedback. This process of adjusting is called backpropagation. So the main goal of training a neural network is to minimize the difference between the predictions from the model and the actual outcome. Now let's go a little bit deeper. So do you remember all of the images of cats we are going to input inside the neural network for training it on cat images? Well, you can do that one by one, so inputting one image every time inside the neural network, training the neural network adjusts itself and then gets another image and so on and so forth. Instead of doing that, so one image at a time, you can decide to do in batches, so dividing the entire database into groups and inputting into the model not one image but a group of images. This helps the model to be more efficient when learning what's in the images and is also quicker. Why is more efficient? Well, imagine that, again, you are training a model on a cat, right? And you have a cat in a specific position. If you give to the model just one picture of that cat, the model will learn that the cat in that position, in that exact position, is a cat. But if you show the model another cat in a different position, it won't understand that that is a cat. So that's why we are giving a batch, a group of images, because we are giving a sample with a cat in different positions. So the neural network is going to take the first batch of images, it's going to process them, it's going to generate an output, and this is called forward propagation. And then it's going to adjust the parameter internally to reduce the error. And this second part is called back propagation. So it's going to take the first batch, it's going to forward and back propagate. Then it's going to take the second batch, it's going to forward, back and propagate until the last batch. The process of going through all of these batches is called epoch. So this is what an epoch is. Different from the epoch, the iterations or steps refers to one update of the model's parameters. So, for example, if you have 5 batches, in a single epoch, the number of iterations will be equivalent to the number of batches that the data is divided into. Through many epochs, the network gradually gets better and better, and we want to make the smallest possible number of mistakes. And in technical terms, we will say that we want to minimize the loss function. So if we look at this picture and we see this orange one is the loss function, the process of training the neural network involves finding the lowest possible point in the function. And this should be the global minimum, which is the lowest possible. In this case is this one, right? But many times it's very difficult to get to the global minimum, so many models will get to the local minimum, which is still a low point in the function, but it's not the lowest. So in each iteration, the neural network will adjust its parameter to take a step towards this minimum, right? Something like this, going down the hill. And is doing that in steps. How big should be the steps is determined by the learning rate. The learning rate is a value between 0 and 1, and sometimes can be tricky to find the right learning rate, because if you have a high learning rate, it means that the network will change a lot during each training. And it can be that it will never find the lowest minimum because the step after a certain point will be too big to achieve the minimum. It needs a lower step. If you choose a low learning rate, you probably will need more epochs because it will take more time for the model to get towards the minimum. So what you need to get, it's like a middle point between a too high and too low learning rate. So keep in mind that if you're using a lot of epochs, probably you will want to reduce your learning rate. Whilst if you're using a high learning rate, you probably want to use lower number of epochs. So now that we know how a neural network works, we can go into Kohya again and set our training parameters. We have train batch size, which is the number of batches again. As I said before, I have 25 images. I tried using 5 batches, so having 5 groups of 5 images. And this was giving me quite good results, but then I found that using a train batch of 2 was giving me best results, so that's what I'm gonna use now. Probably I can show you my results afterwards. Number of epochs, I found that number 4 for me was working pretty well, not changing the learning rate. The learning rate, as I said before, should be between 0 and 1. This is the default learning rate, which is 0.001, and I find that this learning rate with Epoch 4 works pretty well. If I was using Epoch of 2, for example, I would have probably increased my learning rate slightly. Mixed precision, I would recommend it to use it if you can. This is to train the model faster, using less memory. There are 2 types of precision, of lower precision. There is float 16 and bfloat 16. And each of them takes 16 bits of memory. NVIDIA GPU can run operations faster in float 16, whilst TPUs can run operation faster in bfloat 16s. I'm using Windows now, I'm going to use FP16. We discussed about the learning rate. You have here the learning rate scheduler. You have different schedules here. What is it? This is simply a mathematical function which adjusts the learning rate for each iteration. So if you use cosine, it means that the learning rate is going to increase according to the cosine function. Now, if you're fine-tuning a model, this doesn't really matter much. So what I would recommend is just to use a constant learning rate. So this means that the learning rate is not gonna change in each iteration. If you're training from scratch a model, then I think that the scheduler will be very useful. But for now, I'm just gonna use constant. I'm fine-tuning, this doesn't matter much. The learning rate warm-up allows us to start the learning rate at different steps, different time of the training. Also in this case, given that we are fine-tuning a model, in my opinion, this is not relevant. So I will just use 0. Then you have optimizer. The most common one is Adam. So if you open this, you have many of them, plenty. You can try different options. But again, what I would recommend you is to use Adam. And you have mainly 2 Adams I would use. Adam W and Adam W 8-bit. If you have time for training your model, I will go for Adam W. If you don't have time, I will go for Adam W 8-bit. They are basically the same, but Adam W 8-bit is going to train faster, and this means that the precision of the final output won't be as good as Adam W. But you're saving time. I'm going to use Adam W. One important one actually is max resolution. So this has to be coherent with the images you're using for training the model. And in our case, it's 512, so I'm gonna keep it like that. And that's it. So once you are done with that, you just need to press train model, and this will start. And you will see, I'm gonna press it now quickly, and you will see inside your terminal how everything is going. It's going to tell you how many train, how many steps, how many iterations, how many epochs. It's gonna give you a wrap-up of everything, which is quite useful. And you can follow along the training. Usually doesn't take much time, like maximum 20 minutes in my case. Well, it obviously depends on the power of your computer. But yeah, LoRA models should be very quick because you're training with just a few images, and the output is gonna have a very small dimension. Okay, I'm gonna stop my training now because I trained already my model. And I'm going back to my stable diffusion, and I'm gonna show you my model trained. Let's refresh it. I'm in text to image. I'm going to pick the model I use as a base for training my Kohya model. And then what I will do, again, I will pick the generation data from one of the images from Civit AI. I'm going to paste it in here, and I'm going to press this little button. Then I'm going to remove all of these descriptions which I don't want to keep. I'm going to just keep, this light and quality and resolution description, and I'm gonna add the trigger word for my LoRA model, which is a photo of Laura. Laura, I wrote it like that with the number, if you remember. And then I have woman as a class. So you always need to specify that, yeah? And then you need to link the LoRA model inside the positive prompt. Once the model is trained with Kohya, if you go into the training and model folder, you will have all of the models saved. I have these 3 because I was saving my model after each epoch, and I had 4 epoch. And the final model is this one, Laura face. This is the final model after the 4 epochs. Then what you have to do, you need to drag and drop this file, or copy and paste this file inside your Stable Diffusion Web UI models LoRA. I'm gonna show you where. So I have Stable Diffusion Web UI, I have models here, I have LoRA, and then here is where you have to drag and drop and copy and paste the final model you trained. I have many here. So when you are into Stable Diffusion, you can press this for opening all of your LoRA models. And if you click on the LoRA you created, I'm going to choose this one, Laura phase number 8, which was the best in my case. You have the link to your LoRA, and you're actually now able to, generate your first picture with your face. And then I press generate. And this is my, you see, it's my, well, she looks like me. So I find it quite cool. So for example, we can change the prompt as well to have some more, something more detailed in the description. So I have included ponytail. Let's see what happened. So in theory, I should have the hair on the back. You can also add closed eyes maybe. Let's see what happened. Because I was training the model also for having eyes closed. Yeah, here you go. And it's working pretty well, because sometimes when you use normal models and you type eyes closed, it usually doesn't give you eyes closed, and this is quite good, I would say. Or if you write profile, look into the right, and I remove closed eyes. Let's see what happens. Maybe I can add eyes closed in the negative prompt. Maybe we can add restore faces as well. Yeah, and she's definitely looking to the side now. So yeah, that's how it works. As I said initially, I didn't want to give you just a number like this, but I wanted to give you more information on how this neural network works, so that you can decide what's best for you. And you can tweak, all of the key parameters for getting the best result. Sorry if it was too long, but I hope it was useful. So see you at the next video. Bye.